So here's the assignment for chapter 4.5. I'll have this on the video and on the website. And go ahead and time me. This is about how long it should take you with practice. So we're going to draw the sine first. So I'm going to start it right here and end it right there. So I'll mark the middle and then I'll mark the quarters. Sine starts at 0 and then goes up to 1, so I'm going to mark that as 1. This would be -1. Then it's back to 0, down to -1, and then back to 0. So this is 0, 0. This is pi halves, comma 1. This is pi, comma 0. This is 3 pi halves, comma -1. And this is 2 pi, comma 0. Okay, so those are the 5 key points. Again, we should start here. It kind of comes up here, levels off for a second, and then comes down. Okay. Goes like that and like this. Put an arrow on each end and there's a pretty decent graph. If I do cosine, cosine looks like this. So let me label this one. This is y equals the sine of x. And if I do y equals the cosine of x, again, I'm going to do the same thing. I'm going to go down here and I'm going to mark the beginning and I'm going to mark the end. So there's 2 pi and there's pi and there's pi halves and there's 3 pi halves. Where does cosine start? Cosine starts at 1. Starts up here and goes down, hits -1, then back up to 0, and then back up to +1, and that cycle starts over again. So it goes like this, kind of levels off for a second, comes down here, levels off for a second, goes up here, levels off for a second, then goes like that. So just put arrows on the ends. This is 0, comma 1. This is pi halves, comma 0. This is pi, comma -1. 3 pi halves, comma 0. And this is all the way around the circle, full circle, 2 pi, comma 1. All right, any questions there? Okay, that takes less than 2 minutes to graph those accurately and label all the points and everything. We're going to finish most of the notes today. I'm hoping to get done with all of it, but it may take a little bit of tomorrow. And then tomorrow at the end of class, I'm going to give you a quiz. It'll be a sine or a cosine graph, and we're going to take it and stretch it and shrink it, slide it left, right, up, down, all that sort of stuff. Again, the vocabulary we use are amplitude, phase shift, that's a horizontal shift, okay, vertical shift, okay, and we've still got flips and all that sort of stuff, and we change the period, okay, we change how long it takes to graph that cycle. Okay, so let's take a look at what we did yesterday. We started off with just the sines and the cosines. Okay, and we graphed several different sine graphs. We actually graphed 3 different ones. And then our point here is that if you understand how those transformations occur on regular graphs and occur on a sine function, well, the same thing is true on a cosine function. Okay, so let's talk about what each one of these things does again, and then we'll go through and we'll actually do a couple cosine graphs, and we're going to change the period today, which is makes the graphs quite a bit more interesting. So if we look at this A right here, that A is going to be the amplitude. Now, if it happens to be negative, it's going to be a vertical flip. Okay. That D right there is a vertical shift. It's going to slide it up or down. Okay. We had a special name for that C right there. Does anybody remember what that was called? Phase shift. Okay. Phase shift, we just abbreviate that with PS. Okay, remember, the changes with the x do the opposite of what you'd think. And then today we're going to deal with this guy right here, this B. This is called the period change factor. And we're going to talk about what that does, because that's a little bit weird. It's not hard to deal with, but you just have to get used to it. Okay? So what we need to keep in mind is whenever we change the x before the function makes the shape, so we're changing the angle before we even plug it into the sine or the cosine function that makes that wave shape. Okay, so it's going to change the x coordinate on the original graph. Okay, and it does, you'll remember, it does the opposite of what you'd think. So we've talked about what A, C, and D do. We've talked about the amplitude, the phase shift, and the vertical shift. We've done each one of those, but now we're going to talk about what B does. Okay. So if we know what sine and cosine look like from our little demonstration earlier, okay, we want to figure out, well, what would happen if I did this? And I'm actually going to change this. Just notice that in my notes. Okay, we're going to change that to cosine of 2x. So instead of sine 2x, we're going to do cosine of 2x. So you'll notice that the 2 changes the x before the function makes the shape. If we change the x before we make the shape, then we're going to change the x coordinate. If we were to change it after, which is not what this does, then we change the y coordinate. So it changes before the function makes the shape, changes the x coordinate, changes after, change the y coordinate. Okay? And what's going to happen here is we're going to multiply the x by the number b, whatever that number happens to be. Okay, that's going to change the period. It's going to change the horizontal distance needed to repeat the shape of the graph. Okay? So to find the new period, we're going to take the old period and we're going to divide it by b. That's why we call it the period change factor. We'll say that a couple different times. Period change factor. So the new period on the graph is going to be the old period divided by b. Now, this is going to be true for all of the trig functions that we deal with, and we're going to graph tangent and cotangent and secant and cosecant. But for the time being, we're just dealing with sine and cosine. So what's the period on sine and cosine? 2 pi. So the period for sine and cosine is just going to be 2 pi divided by whatever b is. So we've got some specific instructions here. It says graph y equals cosine of x, and then we're going to graph y equals cosine of 2x. And we're going to do this one using a dotted curve, and we're going to do this one using a solid curve. So I'm going to do the original one in black. So you get, again, you'll notice what I've got here is I've marked off all the axes. This is going to start at 0, and this is going to end at 2 pi. So the regular cosine graph starts at 1, down to 0, down to -1, back to 0, and then back to +1. So here's what it looks like. Okay? And again, we'll just do a dotted curve. Okay, this is the parent graph. This is the one that we graphed just a couple minutes ago. Okay, well, now we're going to graph this one right here. We're going to graph y equals cosine of 2x. So I've multiplied the x by 2. I've got a period change factor of 2. So to figure out what the new period is, the new period is going to be the old period, which is 2 pi, divided by the period change factor. What's the period change factor here? 2. So what's the new period? New period's pi. So this completes the cycle in pi units rather than 2 pi units. So this is going to start here, and it's going to end this cycle by the time we get to pi. We're going to end right here. So this is 0 and this is pi. We're going to finish one cycle that quickly. So it's going to go down and go back up in that amount of time. So if it starts at 0, 1, it's going to end the cycle pi units later. So it's going to end the cycle at pi, comma, 1. That's going to be one cycle. So it's going to come down, hit here in the middle. Notice what I've got here. I've got 0 and pi. In the middle, it's going to end up hitting -1. And then in between, it's going to hit 0 at the quarters. So see those 5 key points? So if this is 0, 1, and this is pi 1, what's the x coordinate right here? Hey, Hop. What's the x coordinate right here in the middle? What's in between 0 and pi? 0 and pi? Pi halves. So this is going to be pi halves, comma, -1. Okay, if this right here is pi halves, what's halfway in between 0 and pi halves? Pi fourths. Okay, some angles that we're familiar with. Pi fourths, comma, 0 would be that point right there. And what's in between pi halves and pi? 3 pi fourths, wouldn't it be? So this is going to be 3 pi fourths, comma, 0. So this goes like this. Goes down here. And again, you want to make this a curve as much as you can. Okay. Goes like that. Now, this pattern continues to repeat, so it's going to repeat this cycle again. It's going to come down here, at this point down here, and then go there, and it's going to end right here. Okay, end on 0 to 2 pi right there. Okay, it would continue to go off in both directions. Now, I've labeled 5 key points on this graph. I could go through and label the rest of these, like I could figure out what this point right here is and figure out what that point right there is. But I've labeled one cycle, what we call it, one period of this cosine curve. Okay, any questions? Okay, so the question here is, clearly you can see a difference. There is a big difference between the parent graph that's graphed in black and this new graph that's graphed in red. So the question is, why does y equals cosine of 2x make the shape that it does? Why does it make this shape that seems to be cycling a lot faster than the old graph? Well, think about what's happening to the x. Think about what's happening to the angles that we're plugging in. We multiplied, so multiplying x by 2 speeds up the graph. It makes it cycle faster. So if it makes the shape twice as fast, if it goes through the angles twice as fast, it completes the cycle in 1/2 the time. So the new period is half of the old period. So what would happen if I did, let's say I did y equals, I'll do this in blue. Let's say I did y equals cosine of 4x. How much faster would it make this cycle? 4 times faster. So it would complete the cycle in 1/4 of the time. Do you see why there's kind of this reciprocal relationship, why we have to divide by the period change factor rather than multiply? It's a little bit counterintuitive, but if you look at it this way, we're making it go faster. So we're making this bounce up and down or oscillate back and forth a lot quicker. Any questions there? Okay, go ahead and flip the page over and let's take a look at something like this. This is y equals cosine pi/4 x. This looks like it's going to be more complicated, but let's think about this for just a second. I want to figure out what the period is. I take the old period, whatever that happens to be for the function, and I divide it by the period change factor. So for sine and cosine, which is all we have to graph in this section, the period is 2 pi, right? What's the period change factor here? Pi/4. Now that's not a very fun number to divide by, but look what happens when we take this and we flip that over and multiply. Those cancel. What's the new period? The new period is 8. So it completes a cycle in 8 units. So I'm going to mark 8 right here. The beginning, 0. Are the middle and the quarters easy to figure out? Make sure you eyeball them right. Looks like 4 is about right there. 2 would be about right here, and 6 would be about right here. Have I changed the amplitude? Have I vertically stretched this or shrunk this? Flipped it? Phase shift? Shifted it left to right or up or down? Nope, nothing. The only thing that changed on this was the period. We horizontally stretched this out. Okay, so we're going to start right here at 1. We're going to go down to 0, down to -1, back to 0, and back to +1. And the graph looks something like this. That's what it looks like. And could we label those 5 key points? This is even easier, isn't it? This is 0, 1. This is 8, 1. This is 4, -1. This is 2, 0. And this is 6, 0. Right? Any questions? Piece of cake, huh? Okay, I need you to watch for just a second. Okay, everybody's eyes up here. Okay, I'm going to graph y equals the cosine of x. I'm going to graph the original one. The period is 2 pi. 2 pi is about 6.28. So that would be about right here. So that would mean it ends its cycle right here. It hits the middle at about 3.14, which would be about right there, and hits here at 1.57 and 4.71. So the original graph looks like this. This is actually the parent graph of cosine. Does it look like it's been horizontally stretched? It does. This number right here, pi/4, is about 0.75. It's about 3/4. So by multiplying by 3/4, that's a fraction that's less than 1. It slows it down. So because it slows it down, it takes a little bit longer for it to complete its cycle. Instead of getting done in 6.28, it takes all the way to 8 to get done. Okay? So do you see why we call that a period change factor and why there's that reciprocal relationship here? You would think that multiplying by 7 would speed it up by, or horizontally stretch it by 7. It doesn't. It speeds it up so it shrinks the time that it takes to complete the cycle. Okay? Multiplying by a fraction like 3/4 stretches it out, horizontally stretches it out, okay? Because it slows it down. So think in terms of speeding up and slowing down, and then let's go ahead and do this problem right here. This one's a little bit different. Got a few more things going on. I'm going to change colors and do this one in blue. Okay, we would normally write it this way. We'd normally write negative cosine x over 4 and then plus 2. So we got a couple of things going on this one. I'm going to make this a little bit bigger so we can see it. What does the negative do to the cosine graph? Okay, so that is a vertical flip. Okay. What does the 2 do? Moves it up 2. Okay. What about x divided by 4? What number would that be out front? It would be 1/4. And sometimes it's helpful to think of it that way. 1/4 x. Now, if I'm multiplying by a fraction like that, is it speeding it up or slowing it down? It's slowing it down, right? So if I figure out what the period is going to be 2 pi divided by 1/4. Well, if I take that 1/4 and I flip it over and I multiply, that's a 4 over a 1, so I get 8 pi. The period on this is 8 pi. So here's what I recommend you do. I'm going to do this in black. I recommend that you figure out what's the shape, what's the right shape, and then move that shape. So remember, I'm going to have to take this graph and move it up too. So I'm going to mark my axes about like this. Okay? That's going to be 1, 2, and 3, and -1, -2, and 3. Okay? I still need to mark the beginning and the middle and the end and the quarters. The beginning is going to be at 0. Where do I end this cycle? 8 pi. So I'm going to mark over here at 8 pi. I'm going to mark the middle. That would be 4 pi. The quarters, 2 pi. And over here, 6 pi. So here's the right shape. Well, let's see. This has been vertically flipped, right? So instead of starting at 1 and going down, I'm going to start at -1 and go up. Okay, now, are those 5 key points easy to find? Like, what's the coordinate of this one right here? 6 pi, comma 0. What's the coordinate of this one right here? 8 pi, comma -1, right? Okay, this is the right shape, but is it in the right place? It's not in the right place. What do we need to do? Move it up 2, okay? So if I move it up 2, remember I recommended that we draw a new center line. Okay, so this is running right down the center horizontally. And I'm going to slide everything up 2 units. So I'm going to bump this up 2 units. I'm going to bump that up 2 units, this up 2 units, that up 2 units, and that up 2 units. This is the right graph. And since each one of these 5 points on the black graph are easy to find, aren't these easy to find also? This would be 0, 1. This would be 2 pi, remember this is right along the center line, so that's going to be 2. This is going to be 4 pi, 3. This is going to be 6 pi, 2. And this is going to be 8 pi, +1. Okay, take a look here, because this is one way you can help make sure you got it right. Okay, again, you're going to be drawing kind of your own set of axes and labeling them and scaling them and stuff like that. Okay, Always good to find the center line. Everything on the center line should have the same the same y coordinate. That's a 2 here, and that's a 2 there. Okay? If we're checking the endpoints, it's either going to be above or below that center line, the same amount on a cosine. So this one's at 1 below, so that's going to be at positive 1. That's at positive 1 also. And this y coordinate should be 1 above the center line, so that's at positive 3. Any questions there? Is this pretty easy? Hope so. Let's take a look at the next one, and this one's really important, so I'd make sure you pay attention to this one. Okay, there is something wrong with the way this is written. Okay, now so everybody's got to pay attention to this. This book teaches you how to do sine and cosine and some of the other trig graphs in a way that works, but doesn't translate into more complicated expressions. Okay? So please don't follow what the book tells you how to do as far as graphing these. Please do it the way I teach you. All right? So there is a way to graph this by just figuring out where the points are and then just connecting them with a curve. Okay? I'd much rather have you understand how things are formed and why they do what they do. Okay? And it translates a lot into higher math. So in order to graph these, we want to make them look like this up here. So when I said we can look at it and tell what's been done to it, we want to make sure that this right here is factored so we can see what the phase shift is. If this is not factored, you can't look at it and tell what the phase shift is. So if you'll take a look at this one right here, is that factored? It's not factored, okay? So here's what we're going to do. We're going to factor this. We're going to write this as the cosine of, I'm going to take out pi thirds, and then this would be x minus a 1. Now you can look at it and you can tell what the phase shift is. The phase shift on this one is positive 1. We're going to move this graph to the right 1 unit. So I've got a phase shift. Do I have any other changes to the shape of the parent function? What is this? Pi thirds is a period change factor, right? Now, is this a number bigger than 1 that's going to speed it up, decreasing the period, making the period smaller, horizontally shrinking this, okay? Or is this a number that's less than 1, slowing it down and stretching out, horizontally stretching out the period? Which is this? Speeding up or slowing down? Speeding up. Answer speeding up. Somebody tell me why it's speeding up. Sven. Pi is bigger than 3. This fraction is 3.14 over 3. It's just a little bit bigger than 1. So it's speeding it up just slightly. Okay? So let's figure out what the period is. And even though this looks like it's going to be really awful, it's actually pretty simple, because if it's got a pi in it, we're going to take the old period and divide it by the period change factor. Pi thirds. I'm going to flip that over. I'm going to cancel the pi's. What is the period on this graph? 6. Perfect. Nice whole number. So we're going to start off at 0. We're going to go to 6. So there's the end. The middle would be 3. This is going to be 3/2. And this would be, so that's 1.5. This would be 4.5. Or that would be 9/2. Everybody okay with that? Let's graph the right shape. This is a cosine graph, so it's going to start off here. And I don't have to slide this up or down, so I'm going to make 1 unit here and 1 unit there. It's going to start here, down to here, down to here, then back up, and then back up to 1. So this is, that's the right shape. What do I need to do with that shape in order to get the graph right? Move it to the right 1 unit. So we're going to go to the right 1 unit. So again, this is 1.5. So 1 unit is going to be about right there. So I'm going to put that point right there. I'm going to slide this over 1 unit. So that's going to be about right there. Again, you've got to kind of scale this and figure out where we are. Okay. So if that's about 1 unit right there, I'm going to move each one of these over about that far. And here is the correct graph. And I need to label those 5 key points. So if on the black graph these points are easy to identify, all I have to do is take each one of those and move them. So if this point right here was at 0, 1, all I did is slide that over 1 unit. So that's going to be at 1, 1. I'm only changing the x coordinates at this point. So if that was at 3 halves and I move it over 1, that's going to be 5 halves, 0. If I was at 3 for an x coordinate and I move it over 1, this one's pretty easy. This is 4, -1. If I add another 1 to this, I get 11 halves. Got to be good with fractions. 11 halves, 0. And you label that last point right there. What is this last point? 7, 1. You should be able to look at this and know for sure that you got it right, because how far is it between the start of the cycle and the end of the cycle? How long does it take? 6. From 1 to 7 is 6. Did we get it right? Yes, we did. Okay? Now, remember, this sped it up just slightly. Okay? If I were to graph the parent function for this, I'll do this in blue, it would end at 6.28, so it would have gone something about like this. It would have ended about right there. Okay? That blue graph right there is the original parent graph. It ends by the time we get to 6.28. Okay? We sped this up just a little bit. Okay? Any questions? Okay. This is more typically what you're going to see on a quiz tomorrow and on the assignment. It's going to have all of these things going on here, and we want to make sure that we get this right. So on the side of the page up above, it reminds you that for most people, let me make this a little bit smaller, it's going to be easier if you make the correct shape. So horizontally stretch it and shrink it, change the period. Vertically stretch it and shrink it, change the amplitude. Do the vertical flip, and then take care of sliding it left, right, up or down. Okay? So these little dotted graphs are very helpful because the points on those are relatively easy to figure out. And then all you have to do is take those and change the x coordinate by how much the phase shift is, and change the y coordinate by however much the vertical shift is. Okay? Now, take a look at this last one on this page. Is there anything wrong with this? It's not factored. Okay? So the first thing we're going to do, and I'm going to erase that so I've got a little bit of room. The first thing we're going to write is -1/2 sine of. I'm going to take out a 3. So the 3 comes out front. I'm left with an x. And when I take out a 3, I divide out a 3. And what's going to happen to this pi halves? If I divide pi halves by 3, pi halves divided by 3, I'd take that and I'd flip it over and multiply. So I multiply by 1/3. I end up with pi 6. So this is minus pi 6. Get rid of my work here. And then -1. Okay? So let's figure out, what do each one of these things do to the graph? So what does the negative do? Okay, so that's a vertical flip. What does the 1/2 do? Changes the what? Changes the amplitude. Okay? What does the 3 do? Speeds it up, changes the period, right? So let's figure out what the period is. The new period is going to be the old one divided by the period change factor. So this is going to complete a cycle in 2 pi thirds. Kind of a pain in the butt when the period is a fraction already. Okay, but we can still deal with that. Okay? What's the minus pi 6? Phase shift. Phase shift is, we're going to write that as positive pi 6. And then what does the -1 do, Sven? Okay, moves it down 1 unit. So here's what we're going to do first. We're going to take care of the new period. we're going to take care of the amplitude, and we're going to take care of the vertical flip. We're going to figure out what shape is made by those three transformations. Then we're going to take it and we're going to move it all to the right, pi 6, and we're going to move it down 1 unit. Is everybody okay with that? Okay, so I'm going to slide this down, and we're going to think about that for a second as we scale this. Okay, so I'm going to do this in red, and we'll do a dotted one. Okay, I'm going to need to move this down 1 unit. Okay, and the amplitude is 1/2. So I'm going to do this. This is going to be a half. That's going to be 1. Okay, so this is -1, and that's +1. And the period on this is 2 pi thirds. We want to make this big enough so that we can see this. So I'm going to make this 2 pi thirds. So this is 2 pi thirds. Everybody with me? Okay, if that's 2 pi thirds and the beginning is at 0, the middle would be right here. Again, you want to eyeball it. Do a good job eyeballing it. What would the middle of 2 pi thirds be? In between 0 and 2 pi thirds. What's half of 2 pi thirds? Pi thirds. So this is pi thirds. Let's do it again to get the quarters. What's in between 0 and pi thirds? What is half of pi thirds? Pi 6. Okay, so this is going to be pi 6, which is good news because we've scaled this the exact amount that I'm going to have to move. Okay, that's going to be pretty helpful. Okay, what is this right here? For some reason, and I know what it is, they're fractions. I've got to figure out what's in between pi thirds and 2 pi thirds. It is pi halves. Do you want a formula to help you figure that out? There are a couple different ways you could do this. If you wanted to vision this on the unit circle, this is pi thirds and this is 2 pi thirds. What's right in between? Pi halves. Another way that you can do it is you can use the midpoint formula. Remember the midpoint formula, you add the x coordinates together and then divide by 2. Add the y coordinates together, whoops, and divide by 2. I literally just want to average the two of those, so I add them up and divide by 2. So if I have pi thirds plus 2 pi thirds, isn't that 3 pi thirds? That would be pi, and then I divide that by 2. So this right here is pi halves. So take a look at why this is more difficult. Each one of these, almost every one of these, has a different denominator. Okay, that can make it kind of tough to do these in radians. Okay, degrees it's a little bit easier. Okay, but we ought to be able to do this in radians. Any questions? Okay, again, we're going to take care of these three things. We're going to take care of the amplitude, the vertical shift, or sorry, the vertical flip, and the period. We have already got the period here. So again, I'm going to do this in dotted fashion. Where does the sine start? At 0. Normally it goes where? Normally it goes up, right? What does the vertical flip make it do? Goes down. So it's going to go down to here, back to here, up to here, and down to there. So instead of starting off and going up, it's going to start off and go down. Remember, this is -1/2, and that's +1/2. So if I look at this graph right here, my question is, and this is why we do this little dotted graph, are those 5 points right there, are those pretty easy to figure out? They are, right? Not too bad. I could point to this one right here, and you should be able to tell me what it is. Its x coordinate is pi halves. Its y, sorry, yeah, its x coordinate is pi halves. Its y coordinate is 1/2. This one right here, pi 6, comma, -1. Okay, everybody okay with that? Okay, this is not the correct graph though, because in order to have the correct graph, I have to do a phase shift of pi 6, and I have to slide it down 1 unit. Now, what have I said you ought to do if you've got a vertical shift? What should you do first? Draw the center line. Draw that center line. That center line should be at -1. Okay, so try and make it as accurate as you can going across here. And then we're going to take this and we're going to slide every one of these points Forward pi 6 and down 1 unit. That's going to put me right here. Slide forward pi 6. Notice the scale. That's great when that happens. And then we go down 1 unit. Forward pi 6. That's according to my scale here. Down 1 unit. That's going to put me right here. Okay, everybody watch, please. This point starts on the center line, then goes down to get to the next one. This one starts on the center line, goes down to get to the next one. Looking good so far? Right pi 6, down 1 unit. Should be right back on the center line. Right pi 6, down 1 unit. Should be above the center line. And look, it's above the center line. Right pi 6, it's not marked, but we can kind of eyeball where that would be. And down 1 unit, we're right here. Okay, so please notice, there's the center line on this one. There's the center line with those 3 points on this one. Does it look like we have them right? Okay, so I'm going to connect this with a nice smooth curve. Try not to make it too much like a V shape. Put some nice smooth curves to that. Put arrows on the end, and then we want to label each one of those 5 key points. Pi 6, comma, -1. It's on the center line. Everybody watch, please. Okay, eyes up here for just a second. The nice thing about the sine function, I actually like the cosine better than I like the sine for some reason. That happens to be my favorite trig function. Pretty nerdy to have a favorite trig function. Okay. The nice thing about the sine function is there are 3 key points on the center line. So if this y coordinate is -1, you know this one's got to have a -1, and you know that one's got to have a -1. And where is this one right here? It ended up being at pi halves. This one right here is 1 unit below the center line. Okay, the x coordinate on this is pretty easy to find. It's pi thirds, comma. It would be -1.5, or that would be -3 halves. This one right here is at 2 pi thirds, comma. It's 1 unit above the, half a unit above the center line of -1/2. So this is -1/2. We already got the y coordinate right here. This one's off our scale. How much further did we move this? Pi 6, right? So I take that and I add pi 6. So this is 2 pi thirds plus pi 6. If I make that into 6, that would be 4 pi 6. So what is this guy right here? 5 pi 6. Okay. Any questions? Sure? Okay. I need you to watch for a second. If I were to graph the original sine function, the period for the original sine function is 2 pi. So if this is pi halves, about right here would be pi, about right here would be 3 pi halves. So the original sine function would look about like this. Does this graph look like it's been sped up quite a bit? Change the period. Does it look like it's been flipped upside down and slid to the right and down? So does it look right? Okay. And we change the amplitude there. So it's always kind of interesting on your scale if you can graph the original one and see, gosh, does that look about right? Okay, any questions? Okay, let's take a look at this next one, and then I'll tell you what I want you to do tonight. Okay, so it says, look at the graph and determine what it represents and what function could be used to model the values on the graph. Okay, so this problem is a little bit backwards from what we've been doing. Okay, they give us the graph and they want us to figure out roughly what this would be. And it doesn't even look, well, it kind of looks like it has one full cycle. Kind of looks like it maybe starts a cycle about right there and ends about right there. But that's certainly not along the center line. Okay? This says depth in meters are represented here, and this is the changing tides, and this is time along right here. So if we looked at this and we were to draw a center line on here, roughly where would you say the center line is? I'd say probably about right there. Does that look about right? Somewhere in that ballpark. Okay? So we got the center line there. What about the amplitude? How could we look at this and figure out the amplitude? Maybe around 1.5. You can think of the amplitude two different ways. It's how far the max is above the center line, or how far the min is below the center line. Okay, or the difference between the max and the min divided by 2. Okay, so somewhere in the ballpark of amplitude of maybe, say, should we say 1.4-ish? 1.3, 1.4, something like that? We'll do 1.3. And we said the center line was 3, so that would have moved it up 3. And if this is the center line, would we use a sine or a cosine to represent this? Probably a sine, right? Because it starts here and goes up. So we're going to use a sine. So let's see, if it's y equals a sine b x minus c plus d, which of these things have we identified so far? Got the amplitude, right? So we'll do 1.3. Sine of, what do you think the period is? We got to have a number right here, right? How long does it take it to complete a cycle? If the tide starts right here, or the depth of the water starts right here, and then it goes up and then down, what is it? About 12 hours. So if the period is 12 hours, how do you figure out what that number is? Did it speed it up or slow it down? It normally takes 2 pi. It normally takes 6.28. So we slowed it down. Okay? We're expecting a number that's a little bit less than 1. Maybe quite a bit less than 1. Okay, so the formula is the period is the old period, which is 2 pi divided by b. What is the period? We can look at it until the period's 12, right? So this is going to be 12 equals 2 pi over b. So let's figure out what b is. B would be 2 pi divided by 12, so b would be pi 6. So we can put a pi 6 right here. And a phase shift. How much forward did we move this? If this is 4 a.m., this would be 2 a.m. That looks like about how many hours? Well, if this is 2, that looks like about 1 hour, right? How do I move it forward 1 hour? Okay, so I'm going to do x minus 1. And then I've got one last thing to write down. How do I take this graph and bump it up 3? We're going to put a plus 3 right here. Okay? Yeah. Because we started it right here. Okay? So normally the sine curve would start on the center line and go up. It starts forward of that point right there just a little bit. Looks like about 1 hour according to this scale. Okay? Any questions? Okay, so I am going to do more of these tomorrow. I've got 4 more graphs. This is typically what you're going to see on the quiz. It's not going to be a very long quiz. We'll do it at the end of class. Tomorrow I'd like you to come with a fair amount of the assignment done. You'll probably have about a half hour or so in class to work, and it would be really great if you could be done or almost done with the assignment when you walk out of here, okay? So you're going to have a quiz on problems that look like this tomorrow, so I would practice those. Come tomorrow with questions. I'll take questions for about a half hour, and then we'll do the quiz. So you have about that much time to work. Over the break, you can maybe fine-tune this a little bit. I know it's going to be out of sight, out of mind for a while, but hopefully you'll work on it just a little bit, and then we'll come back and finish up the chapter after the holidays. Okay? All right. Thank you very much. Have a great day.